Hey everyone! Today I am going to be trying to index some Ruby gems and look at the source code. I am interested in how many gems are trying to work around or work using threads basically and have potentially like thread related issues in them. And in order to do this, I want to just have a look at, say, the top 100 or top 1000 gems, which we can pull down from this page here. So what I want to do is I want to download these gems and look at the source code, and maybe to start with, just see how many of them use threads or mutexes or semaphores or condition variables or any other kind of like thread related construct. I guess what is interesting is what I've noticed is some code that you can't imagine would use threads actually has some kind of shared internal state. And I find that quite fascinating because I think it shows that there are potentially issues with a lot of code without consumers of that code necessarily being aware of it. So I'm just interested, like what percentage of, like, say, the top 100 gems actually potentially has thread related issues. And I guess that comes back to, I guess you have gems which do things like they're directly concerned with parallelism, and so threads make sense, or they are trying to expose a thread-safe interface but internally have, like, say, caches or other data structures which are shared between objects which otherwise look immutable or maybe unimmutable, but internally they have some shared cache or some shared storage or data or something, so there needs to be locking and mutexes around it. And I guess the interesting thing that comes out of that is that when you look at threads and mutexes, they're not safely composable. So it's easy to have code deadlock if you take two functions which both have internal state and you try and put those things together in a single function. It's possible. Actually, it's impossible to take code that uses threads and guarantee its composition is safe, which is quite a fascinating result. I'll probably look it up and I'll add that in a comment because it's kind of a pretty deep topic, but I won't go any deeper than that right now. So the first thing I need to do is I need to grab this website, and I guess we can only get like 10 things per page, or maybe there's like a count. So we're just gonna have a page, and we're just gonna enumerate and pull down all those pages and scrape the data out. There's a couple of ways we could do this. You could use a regular expression, which, like, is probably okay, especially because we're just looking at a very specific pattern. The other option would be to do something like Nokogiri and parse the document and then use a CSS or XPath query to pull out the elements that have the links. Then once we have a list of links, we can fetch those. There's actually a gem fetch command that I was just told about, and so we can execute gem fetch and it will pull down the archive that contains all the code. Then we can extract that, and I guess there's a couple of ways that you could analyze the code. One way would be to use just a brute force approach, again, like regular expressions, look at all the source code files in .rb and see if they contain the keyword thread or mutex or semaphore. The other option would be to look at doing some deeper analysis, like using the parser gem and parsing the code and having a look for the symbols like thread. To be honest, I'm not really that concerned. I guess we can look at if the keyword thread shows up once, then probably it's a very weak indicator. But if we have like that keyword showing up a number of times, then it's a stronger indicator. So we can maybe look at weighting those results. Anyway, let's have a look if we can pull down this index. So I'm going to use async internet just because I think it's going to be faster. And then what we want to do is I'm just going to grab this. And what I want to do is I want to make a cache, a local cache. And I'm thinking there's a couple of options. For example, we could use like a YAML file for the data we're extracting and just have like a page1.yaml or something like that. Because I don't really want to hammer their server over and over again. I just want to download this data set once. Okay, and then I'll have another part in the pipeline which can just read those cache files and do the next step. So we might grab 100 pages, and that's 10 gems per page. It's 1,000 gems we'll get metadata on, and I'm okay with it. We'll pull that down. Now we can do this sequentially, or we can just whack it in a semaphore, which means that we don't completely destroy their server infrastructure. I don't think we'll be able to do that anyway. So we'll just do 32 simultaneous requests. And we want to wait for everything to be finished, so we're going to make a barrier as well. A barrier allows us to wait on everything until it's finished. Right, so let's get that, put that there. I think I'll try NoHaguri to start with. This will just go forever. It's probably like a bad idea, but it's okay. It just puts some robustness in the handling. If we get rate limited or something. Okay. So what does this markup look like? H3 tag. I'm kind of interested in just the number of downloads as well. It could be kind of a useful metric to keep around, because at least it should be a factor in how you weight how important it is with like I'm pretty sure RSpec core uses threads, and because it's downloaded 480 million times, that's quite a big indicator that there's potentially issues, because a lot of people use that code, and if that code has race conditions or bugs, well, I guess it only affects your tests, but what is it, impact times surface area or something. It's good coffee. Okay, right, so let's have a look. It doesn't really seem like there's a container for all these things. They're just kind of smushed out there. But I guess at least we can pull this class out. So let's just start with that. Okay, I guess I'll bust open a terminal, put that there, put that there. I probably need to add a gem file. Okay, we have something. We don't have anything. Oh, I've got an empty array. Empty array. Oh, I know what I did wrong. My selector was totally foobar. Okay, that looks confusing, but okay, so inside that we have a whole bunch of H3s, so we actually just want we want that bit. Okay, that's starting to look a bit better. Does that work? Okay, that does work. Okay. Okay. They are using bar width. Okay, that's their thing. Okay, I see. Okay, so we can pull out the percentage. So we got the bar element, and we just want to get H3 and a text, and then what was the other one? There's a div that contains a number. Oh, it's got a span as well. I guess we can just pull that out. It's a bit more reliable. And we want to get the percentage. It is that thing. And I actually don't know how do we access data stuff. In jQuery you just use the data function, but I'm guessing that's not how it works here. Okay, that's good. That's what we wanted. I guess you want it as a floating point number. It's a little bit of that will blow up if it's not a floating point number. So better to have an exception than silent data corruption. Or not, I don't know. I don't know what you like. Maybe you like silent data corruption. Okay, so we have those three things. Now, I feel like we could use the YAML-p store. It's not that great, but it's not that bad either. It's sort of like a really crappy single-threaded transactional database, which actually fits perfectly with async since it's single-threaded. So what we're going to do is for each page, we're going to open the database. And actually, to be honest, I guess what we can probably do is so this will be our cache, and we just won't do this whole thing if that file already exists. Okay, right, so what we want to do in here is store.transaction do I kind of prefer this. I think this is okay. I don't really like implicitly accessing the store just because the transaction has started. Okay, right. Root. Actually, what we could do is we just set up the basic stuff here. Store transaction. That's going to work, right? I'm pretty sure I've done that before. Let me try it. Okay, great. It does come as a first argument. I just think it's ugly to have this, which somehow within this block becomes mutable. It just is against my sensibilities to write store square bracket something. I want to have something like this. Right. So root. So we're just gonna save the time we did the fetch, and we're gonna make an empty array for all the gems, and that's gonna stick it on disk. Actually, to be honest, that's probably not a super great approach because it would be nice to commit all of the gems in one go. But this way we'll incrementally add them. I don't know, I guess it depends on what what kind of failures you want to deal with. This will incrementally add them to that file. But if this blows up halfway through, we'll have a page -7 with 5 entries in it or something, which is not quite right. Anyway, who cares? Okay, so we are going to add into that array name, percentage, count. Is that everything we can get from that page that would be vaguely useful? I think it is. So rather than going totally ballistic and destroying everything, let's just start with 2 pages. See if anything works. Oh, it worked. That's funny. Oh, page 0 and page 1, and they're both empty. Epic. Oh, I know what happened. I guess we forgot to wait on the barrier. Something worked. This wasn't what we wanted. Ensure internet. Gotta close the internet once you're done with it. Is that in the right place? No, it's not. And neither is that. I really love the new block syntax with Ruby that just lets you put ensure inside blocks. It was so genius. It makes code so much more pretty to look at. You're gonna have to have like tons of really ridiculous nesting with exception handling. Okay, right. So we're closing the internet after we're done. We're waiting on the barrier for all work to be finished. Yeah, I guess we should delete those, and we probably should start from page 1. Okay, what's going wrong? Store transaction root gems, add that thing. Oh, I think I know what's happening. I think that unless you actually touch the root key, it doesn't update, it doesn't save it, which is pretty glitchy. Let's just double check that we're adding stuff. Yeah. That's interesting. It's sitting there. So async uses a gem called console, and console has some environment variables which let you debug stuff. And in this case, I would like to break on that, but let's just see what's going on. Of course. Okay, let's just get rid of that because we don't. You know what? We should have like logged the error. That came back to bite me. Why? Hold on. Wrong place. There we go, invalid. Why is that not? Invalid value for integer. Yes, that is an invalid value for integer because it's got commas in it. How do I turn an integer with commas into a number without something really horrible like gsub? That's not what I wanted. Oh well. I guess that's okay. Okay, great. Name, percentage, count. So the next thing I want to do is I want to fetch all of these things. So I'm just going to make a pattern that will match all of those files on disk. I'm happy with that approach. Maybe it is silly to have separate pages as separate files. Or maybe I should have pages and build a sheet like combined index. Because it's kind of annoying to have to read all of them. Oh, who cares? Right, let's see if that directory.glob. Okay, great, that picked that stuff out. Now, do I want to write to these files or not? Probably not. So I can just use gamma load file. So even though up here we used a pstore, which we didn't really have to do, but we did anyway, down here we can just use gamma load. That's okay. Okay, we need to fetch it, but only if it doesn't already exist, and we don't know what the version is yet, so gem fetch rspec. How does that work? What does it do? Okay, so it downloads the gem data. Okay, that's awesome, but I don't want like a million gem files in the root directory. So we'll just jump into the cache root for doing all that stuff. Okay, the tar archives. That's useful. Okay, what are we going to do? I guess we don't actually have the path to the gem here. I don't know, we can just make this another step. So we're going to match all star.gem files in the cache root. We're going to go all over the. We're going to go over those, and we're going to tar xvf. And I don't know if that's going to work, or it's just going to create a huge mess in that directory. Okay, that made a huge mess, and in fact all of that stuff we don't really Is there a gem command that will help us do it better than that? Just gem extract. Hmm. Gem unpack. That's more like what I was after. How does that work? Does it just download it if it needs it? Okay, awesome. We'll fetch it first and then unpack it. That is perfect. Brilliant. Someone thought of this use case already. Okay, perfect. Don't need to do that. Gem unpack gem name, and that directory should give me all the source code I want. Let's try running that. That is awesome. Okay, so I have all of this source code now available to me, which is pretty much perfect. So let's just look for one keyword. And I think rather than trying to write this manually, I might just use grep, because grep is pretty optimal. To start with, I'll just do it synchronously. I'm okay with it. It's not like I have, actually, yeah, I don't know, like 1,000 gems. I wonder how long that will take. Even if it's just like 10 minutes, it's probably not worth the effort running the code to make it run in parallel. But there's some pretty cool gems out there for doing stuff in parallel. Also, I've heard. Right, okay. We want to use this again. And what we want to match is just basically anything that has a lib directory. Okay. Grep-c. Okay. So Rake has this thing called sh. I don't know if it supports options or not though, but it should do. I guess it's giving like a total count per file. Using a pipe is not so convenient with SH. Awesome, there we have it. So is there anything unexpected? Not really surprised Times in it first have it. Rec has it once. It'll be interesting to look at the correlation between global state and this number. Gems that tend to have a lot of shared mutable or global state would tend to have to deal with threads a lot more. I mean, in an explicit sense. Because as soon as you have shared global state, if then you assume you're using that model, like users may use your code in a multi-threaded environment, then you would naturally feel inclined to put locks and mutexes and semaphores and other stuff around your code to stop it from self-destructing. But I think that if you take a pessimistic view on this, you sort of go, okay, we kind of accept that threading is pretty tricky to get right. And if you write your code in a way where things like mutexes are necessary, then do you feel confident to assert that your code is actually got, not just does it have the right number of like mutexes in the right place? Like, have you've put some in there, but have you put all of them in that are necessary? And I guess the question is, or becomes, are you confident that you're writing thread safe code? You know that your code has got shared mutable state, so you've put some threads and some mutex kind of things in there, but are you confident that you've managed to cover all possible ways that could potentially happen? And I guess experience shows us, like, generally no. The answer to that question is no. There was a really fascinating Google recently added a race condition detector into the Linux kernel, and they found tons of race conditions apparently. I don't know all the details about it, but you know, if people who write the Linux kernel have race conditions in their code, then like what hope is there for the rest of us to write code that doesn't like blow up in weird situations? And I guess the really tragic part of that is that I mean, yeah, I've lost my trail of thought there, but it may come back to me. Anyway, look, I'm just going to leave it there. I hope this was interesting, and I hope that I can find some interesting numbers and get some interesting insights about how threads and their various different ways of being used exist in Ruby. And I think there'll be some surprises. I think there'll be gems that come up, popular gems that we didn't really necessarily anticipate using threads. And I think my key point really is that should be a concern, because threads are really difficult to get right. Anyway, look, thanks for watching, and hope you tune in for the next one. Like and subscribe and all that junk, and feel free to follow up with any questions or comments.